Let's read the question, class. If NaCl is doped with 2 into 10 to the power minus 5 mole percent of BaCl2, then the cation vacancies per mole of NaCl crystal will be. The options are 6.02 into 10 to the power 23, 1.2 into 10 to the power 17, 1.2 into 10 to the power 19, 6.02 into 10 to the power 18. First of all, we are discussing about cationic vacancies. Therefore, we should know that the number of cationic vacancies will be equal to number of Ba2 plus added in the system. So, we can calculate the number of cationic vacancies will be equal to the amount of BaCl2, 2 into 10 to the power minus 5 mole percent. The value of Na will be taken as 6 into 10 to the power 23, which is already given. When we multiply numbers, we get the value as 1.2 into 10 to the power 17. Therefore, the correct answer is option number 2. Let's move to our next question, class, which is question number 57. Let's read the question, class. A compound formed by elements A and B crystallizes as a FCC lattice. If A is present at the lattice points of unit cell and B occupy half of the tetrahedral voids as well as 1/4 of the octahedral voids, then the formula of the compound will be A2B5, A3B2, A4B5 and A2B3. First of all, we need to know that we are discussing about FCC unit cell, and for FCC unit cell, the number of atoms is equal to 4. Since A is forming the lattice, the number of A will be 4. Let's talk about the number of atoms of B. B occupy half of tetrahedral voids. Therefore, it will be half into 8, because the number of tetrahedral voids will be double the number of atoms, plus 1/4 of the octahedral voids. Therefore, 1/4 multiplied by 4. Since the number of octahedral voids will be equal to the number of atoms making the unit cell, therefore the number of atoms of B will be 5 and the correct formula of the compound will be A4B5. Therefore the correct answer is option number 3. Let's move to our next question, class, which is question number 58. Concentrated aqueous sulfuric acid is 98% H2SO4 by mass. How many grams of concentrated sulfuric acid solution should be used to prepare 250 ml of 2 molar H2SO4? The options are 98 grams, 50 grams, 110 grams and 100 grams. For this question, we need to calculate the mass of H2SO4 which is required to prepare 250 ml of 2 molar sulfuric acid. We can calculate it by multiplying 250 by 2 into 10 to the power minus 3 multiplied by 98, which is ultimately equals to 49 grams. We have already calculated that the mass of H2SO4 required is 49 grams. So, we can see that 98 grams of H2SO4 is present in 100 grams, as it is already given. The mass percent of H2SO4 is 98%. Therefore, we can calculate that 49 grams of H2SO4 is present in 100 divided by 98 multiplied by 49, which is ultimately equals to 50 grams. Therefore, the correct answer is option number 2. Let's move to our next question, class, which is question number 59. Which concentration term is temperature independent? And the options are molarity, next is weight by weight percent, next is weight by volume percent, and the last option is normality. Class, for this question, we need to know that any concentration terms which has volume in it depends upon temperature, because volume changes as the temperature changes. So molarity will be temperature dependent species because it has volume. On the other hand, weight by weight percent will not depends upon temperature because it do not has volume term. Next we come to weight by volume percent. It will depends upon temperature because it has a volume term. The last is normality. This will also depends upon temperature because it has volume term. So the correct answer is option number 2. Class, let's move to the next question. Question number 60. Let's read the question. A solution containing 8 gram per decimeter cube of glucose is isotonic with 5% mass by volume solution of a non-volatile, non-electrolytic solute. We have to calculate the molar mass of the solute. The options are 250 gram per mole, 150 gram per mole, 400 gram per mole and 500 gram per mole. First of all, we need to know that for isotonic solution, the osmotic pressure of first solution will be equal to the osmotic pressure of the second solution. By this, we can conclude that the concentration of both the solution will be equal. That is concentration term for first solution, that is a solution of glucose, will be equal to the concentration of a non-volatile solution. So we can calculate the concentration of the solution of glucose, which is 18 upon 180, as the molar mass of glucose will be 180. We can calculate the molar mass of the second solution by using the formula 5 upon molar mass multiplied by 1000 upon 100. So the molar mass of the solution will be 500. Therefore the correct answer is option number 4. Let's move to our next question, class.